This session is on file carving laboratory experiment and state that the training is an end-to-end walkthrough covering four major tools. Autopsy, which is a forensic case and file system analysis based tool. PhotoRec, which is structure-aware carving. And Scalpel, which is header footer carving. And Foremost, which is a classical signature-based carving. The monospace line identified the exact evidence image and case name used in the lab. So NPS 2009 Canon 2 Gen 1 image is downloaded from Digital Corpora, and the case name we kept for this is file carving lab 01. So this slide defines the scientific goal of the lab and the skill student or the learner must gain. The objective block states that training will cover JPG photographs from a Canon camera card disk image using two complementary approaches, file system analysis and file carving. Then compare both methods. This comparison is the heart of experiment. File system analysis uses directory entries and fat metadata to show named files, for example, photos under 100 Canon folder, while carving scan raw bytes for JPG signatures even when names and folders are missing. The learner outcomes then break the goal into four measurable skills. First, the student must explain when directory browsing is enough and when carving becomes necessary. For example, after a format heavy deletions or damage fat. Um, Second, they practice header footer carving with Scalpel and Foremost tools. Third, they use the PhotoRec for more format-aware recovery. Fourth, they document offset, file counts, validation evidence, so findings are reproducible. For example, after the format carves 30 JPG images, the student should record uh, or you should record that count, open sample images and note bytes offset from audit.txt file created using the Autopsy. Then compare those results with Autopsy 100 Canon listing. So this slide documents the complete evidence profile for file carving lab 01 in a structure table. It records the investigator, my name, host name, which is host 1, source image, which is NPS 2009 Canon 2 Gen 1 with an extension of E01, working raw image, which is NPS 2009 Canon 2 Gen 1 dot raw. So the E01 is changed to the raw image first. Then approximate size is around 30 MB and volume label is Canon underscore DC. File system we're going to investigate is FAT16 and the photo folder is 100 Canon folder. Then the note at the bottom explain that this is a digital corpora NPS style Canon training image which is ideal for practicing deleted or recoverable photographs. In forensic works, this kind of evidence is essential for chain of custody style documentation. Anyone reading the report must show how exactly which image was analyzed, in which format, under which case identified. For example, if a Autopsy initially fails to open the .e01 file, the table still shows that a converted raw version was used for carving with PhotoRec, Scalpel, and Foremost. Likewise, knowing the file system in FAT16 and the volume label is Canon underscore DC help the analyst expect the camera card layout and look first for the Canon 100 Canon directory before carving unallocated space. So this slide inventories every tool category used in the lab so learner understand the full tool chain. Under platform and forensic analysis, it lists Kali Linux as the operating system, a Topsy Classic Web UI on port 9999 for case management and browsing. The Salute Kit has underlying file system engine and EWF tools slash libewf for reading expert witness format, that is .e01 disk image, And under carving tools, it lists PhotoRec 7.2, Scalpel 1.6, and Foremost 1.5.7, which are the three carving engines compared later in the experiment. The, the sporting section lists ewf export, ewf info, and image underscore stat, which are used to inspect and convert forensic images before autopsy can analyze them. This matters because the lab is not a single tool demo, it shows how acquisition, format, sport, file system parsing, and carving tools work together. For example, if autopsy cannot determine the E01 image format, the learner uses ewf info to verify the file, then ewf export to create a raw image, and then img underscore stat to confirm the raw image is readable, and only after that run Scalpel or Foremost against the raw file. Recording tools version PhotoRec 7.2, Scalpel 1.6, Foremost 1.7 also makes the experiment repeatable for grading and other evaluations. So this slide teaches the core conceptual contrast of entire laboratory. On the left, file system analysis is explained as recovery that depends on the metadata, directory entries, FAT or MFT structures, timestamp and names. Its strength is that recovered items keep original names and paths. Its weakness is that it fails when metadata is destroyed. On the right, file carving is explained as scanning raw bytes for headers, footers, or internal file structure. Its strength is that it still works when the file system is damaged. Its weakness are loss of the original file names and possibly false positives. The bottom sentence state that this lab performs both methods and then compare results. This comparison mindset is critical in real investigation. For example, in autopsy, a student or a learner may browse the Canon underscore DCV folder or 100 Canon subfolder in the Canon DC folder of the disk image and see names with JPG files extension with dates starting from some specific dates. Separately, Scalpel may carve 30 JPG images from the disk image which we have taken and named by offset such as 00000 160.jpg. So initial starting with zeros and then 160.jpg with no original camera file name. Both output can be valid evidence. One proves that what the file system still knows, and the other proves what content still exists in raw data. So this slide explains the classical signature-based carving algorithm used by tools like Scalpel and Foremost. It lists 4 steps. First, scan the disk image for a known header. Second, search forward for a matching footer or stop at the configure maximum size. Third, extract that byte range as a candidate file. Fourth, validate the candidate by opening it or checking its internal structure. The green example box gives the JPG signature used in this lab. So headers are usually starting with FFD8. So it's an example FFD8, FFE0, EXIF or FFD8, FFE1, and the footer is ending with FFD9. This is the practical heart of the header footer carving. For example, when Foremost processes NPS 2009 Canon to Gen1.raw file with -t JPG, it search for JPG start maker, extract data until FFD9 or until a size limit, and write files into Foremost out /JPG folder. And in the actual experiment, both Scalpel and Foremost reported around 30 carved JPG images, which demonstrate that the same header footer rules can produce consistent result across tools. So learners should be able to understand that if a JPG is truncated or fragmented, a footer may never appear. So validations remains mandatory. So this slide covers the first practical autopsy action in the lab flow work. The action list tells the learner to start with classical Autopsy web interface as local host 9999 port, create case file carving lab01 and create host lab host 1 with investigator name. The red why this matter box explain that a case container preserve a case chain of custody style organization. Evidence path, examiner identify, and notes that can be reused in the final report. In forensic practice, skipping this administrative setup causes confuse can cause confusion later when multiple images, host or analyst are involved. For example, if two learners carve the same Canon image, but one named with the lab test and the other is using file carving underscore lab01, screenshot and autopsy export both become hard to grade or compare. So creating host one also prepare autopsy to attach the disk image under a name host which matches both classical autopsy organizes volume like C inside C FAT16 before file carving before file analysis begins. So this step therefore connects training disciplines to professional case studies or hygiene. So this slide explains the first attempt to add the original expert witness image, that is E01 image, and the failure that student or the learner might encounter. The action section shows that the data source path, like on my system, it was in download folder. I created the images and I put my E01 image, which is part of the disk image, in this folder. And note that the split image warning should be confirmed that this lab uses a single part. So E01 is a single part of the whole image. The observed error is quoted exactly the image format type could not be determined for this image file. So the red box explains why this is critical. Autopsy, the salute kit could not decode E01 image or the E01 is a part of the image. So no file system view and no reliable analysis are possible until the issue is fixed. So, so this is valuable because it captures a real troubleshooting moment in the experiment. For example, the next correction step are to install EWF tools libewf and verify that the file system verify the file with ewf info and convert the image with the correct ewf export syntax with -u option which is for unattended mode and with -t option for output basement base name into a raw image such as nps 2009 canon 2 gen1.raw. Only after that conversion can Autopsy import the image as FAT16 and can PhotoRec Scalpel foremost carve JPG successfully. Go to Digital Corpora website. This time we'll download some Canon image. We have various images. Let's download the generation 6 image. So it's started downloading. So the image is downloaded, is in uh, download folder. So I'll put in the download images folder. So this is the Canon Gen 6 .E01 image. I want to create a raw image for this first. So I'll see, like, I already have the images forensics and images folder. So here I'll get Canon Gen 6 raw image as well. So let's go to the download folder again, and to generate the raw image I will use ewf export tool. So ewf export forensics images. So inside this, uh, I want to create nps. Oh, what is this? nps and 2009 Canon Gen 6, and then I will write my home download folder location, home Kelly downloads images nps Gen 601. The name is correct, so I'll correct the name. I have to use here option -u and -t. So you can see a raw image size of 29 MB is created. So we'll go to the forensic, go to the images, we'll see the Canon RAWs, Canon Gen 6, Canon 2 Gen 6 raw images has been created. Now let's start the lab. We will start the Autopsy. So I'll create new case this time. So let's name it as file carving lab 03. So all this is optional. Click new case, add the host, but the host name is host1 only, and add host. The host has been added. I want to add image, add an image file. So location I will give is this raw location. Slash and the file name. The type will be disk only, and the import type will be symlink only. So next, so let it be. So it has identified as DOS FAT16 type disk. The sector it has identified, so change it to FAT16 and then add it. Okay. So disk 6 has been created, so it has shown the two partitions. Now here you select the C and then click on analysis bar. Now here you can click over the file analysis. So you got this disk and here you can click over the Canon underscore DC and you can click over the metadata here. So you get the metadata report. And so MD5 hash, SHA1 hash, other details are available. So you can go back to the file analysis, then go to the DSM image, and here you can select 100 Canon image. So here del means deleted. So all these files has been deleted and we have to recover these files. So you can see here these files, the del means deleted, so all these files are deleted, so we have to recover these files from its metadata. So let's see how we do this. For recovering the images we'll use PhotoRec tool. So we here you can see is asking for the disk. So we have selected the 31 MB RO disk here, and it's showing partition with FAT16 1P FAT16, and we have to select this partition and then other we have to select. So here is the complete directory. As you can see, it's asking the please select a destination to save the recovered file. So we need to select a destination folder. So let me select the forensic one. Forensic folder I selected here. You can select any destination folder. So forensics, let's suppose in images. So you can see here uh, the recovered file is stored at this location. So we will check this. As you can see, it's written the recovery completed. So if you see the folder, So this is the folder we were having at this location, and if you see, I have opened the location in this file. The deleted image files has been recovered. As you can see, the image file are either starting with, I mean, all are the JPG image files, and the image file name are either starting with character F, or they are starting with character T. So those who are starting with F character, they are the primary carved JPG candidates, and those who are the T those starting with T are the thumbnails. So thumbnail shows readable numbered screen photos. So or are related to the JPG streams. This recovery.xml file shows the recovery log. So what we have observed is, uh, inside the Autopsy we went to 100 Canon folders. There were images, but the original file names from the 100 Canon folders are not preserved. So they are deleted images. But we are still able to recover viewable pictures from the raw bytes. So for this purpose we have used the PhotoRec tool. So PhotoRec tool is able to recover even if we ignore or lose directory names. Next we are going to use a tool called Scalpel. This is for the carving using header and footer. So Scalpel is a command line file carving and digital forensic tool used to recover deleted files from the raw disk image or storage partition by matching the headers and the footers. To use Scalpel, I will create a new folder and do my experimentation in this folder. Now I move to this folder. So I am under the new folder. Now I will copy the configuration file I forget to put dot, so in this folder it will copy, and then giving the sufficient permissions. And then I will open this file. So I have opened this file. Now what I have to do is I have to enable the JPG header footer rules to analyze this using Scalp. So I'll find out the lines where JPG is written. So you can see here JPG is written here. So I'll just remove these hash values. That means I will enable this. So I'll see. Likewise you can do for other files as well. Right, so after doing after enabling the JPG files, I will write it and I will exit from this, and then I'll to use the Scalp tool. So there are 37 files are available. So using this header footer carving, also I can recover more files. So there are total 37 um, JPG files are there. So from the header footer rules, I can do this. I can recover the files. Now you can practice various commands to see the details. For example, this ls-lh and the location of the output folder and jpg star will display all the images files which are recovered from the image. And then there is a command called using cat command and the folder of output, and Scalpel creates the audit.txt file, right? So you can see here inside carry scalp output, it creates an audit file. So you can open this uh, file and you can see the details. So it will display the file start, job, length. So all the files details it shows to you. The important information that we want to gather is this information. Like I have written a script and I executed the script. So it displays all of the memory records. So for all of the image it is showing the information. The important information to note down here is the JPG files. Its footer, it's the the footer part end with ffd9. So for JPG, for different images, type of images, the header part and the footer parts are different. Like for GIF, the footer part is 003b. For JPG, it is FFD9. So whenever at the end or at the footer you will get FFD9, that means it's a JPG image, and the header part is also fixed. The header part for the JPG images is FFD8. So you'll get an idea when you see the detail view also. So you can classify which is the header part, which is the footer part. So header part is starting with ffd 8 and ending that footer part is ending with ffd9. So this information you can gather from the detailed view. Now there is another command, like from the recovered JPG images, if you want to open it, like image file name started from 00, so you can check what is this image. So it will open the image and display it to you. So you can likewise you can open an image. Since images number are starting from uh, 00, so if I'll open 35, it will display the 34 image. So you can open and check the image. So that means the image files has been recovered successfully. Like you have the Scalpel tool, there is another tool called Foremost. So let's install the Foremost. Now Foremost is an open source command line program used for file carving in digital forensics. It recovers file from disk image or raw drive by searching for a specific file header, footer, and internal data structure, completely ignoring the underlying file system. So it's used in data recovery, file system agnostic, malware analysis, target extractions. So these are the important uses of the Foremost. So you can see the Foremost has been successfully installed. The next is to create a folder, an output folder for Foremost. The folder has been created. Now we'll use the foremost. So processing is done. Let's verify. So it has created an audit file and a JPG folder. So there are 30 files. So Foremost is able to recover 30 files in the JPG folder. So let's see the audit file. So for all of the 30 files, the files are starting from 0 number. For all the 30 files, it display the information. Like I was having a script for the Scalpel, I'm having a script for the Foremost as well. So the long script, I'm not explaining the script right now, but this script is again to show the detail information. Um, so I'll run Foremost script. So you can see like Scalpel was displaying the records to me. So Foremost script is also displaying the records to me. So similar informations I can get. The starting for the JPG images is uh, is this, like total 30 images are recovered by Foremost. So here starting for the JPG images is FFD8 and ending is FFD9. So you can see the detail view as well. So we can get more details using Foremost tool as well. So this conclusion slide summarizes the key lessons of the whole file carving laboratory in 5 points. First, file carving recovers content from raw images by using signature. Second, header-footer carving with Scalpel and Foremost is simple, explainable, and effective on this Canon training image. Both tools uses around 36 JPGs in practical run. Third, PhotoRec adds format-aware recovery and convenient output folders such as carved Canon 2.4 with report in a report.xml file. Fourth, Autopsy file system analysis preserve names and timestamp that Kaveh usually loses, which is why browsing 100 Canon folder remains important. Fifth, best practice is to combine file system analysis, carving, validation, and then documentation if required. So this slide is the take-home message of the Autopsy practical. For example, a complete lab uh, would say that Autopsy shows the FAT16 Canon volume and name photos. Scalpel and Foremost each carve images with signatures like JPG images with starting signature FFD8 and ending with FFD9. And PhotoRec recover viewable images without original file name, and all results were validated by opening files and recording offset logs. So that combined workflow is that professional um, examiner can use this, or I mean the investigator can use this in a metadata forms which may be partial, like recoverable from the damage image or recoverable from the incomplete image. Thank you.